This is Siobhan, welcome back. This is actually being recorded as part of a live stream for the 2D tutorial, but what we want to talk about is how to use interfaces with GDScript. That's, I think, a soft principle leaving this. These are commented by saying, like, is it a laser if health is like, you see how like, you start power ups. By saying like this knows how much damage laser perhaps has its own value. Do we just say like, it's odd laser, then equal, you know, up here would say like, if laser, then do like minus equals 5, if missile, then do minus equal 20. You can hopefully see how that's already really bad. As we've changed. If we do this, game over happen dot emit signal from here, well, what? All of the enemies are going to get it. You know what I mean? Because all the enemies are subscribed to it. So it's like, are they all then going to take damage? How do you make sure that it's only taking the damage of that particular enemy? Oh, well, I could pass in the other area so that it can check to see if it's itself. At this point, if that even makes sense to you, then good job. You're, you know, pretty good. You're advanced to a certain level, but don't do that. You can see how it really starts to get icky when you do all that. So you don't do that. Instead, what you would do is use interfaces, perhaps. But guess what? We don't have interfaces. Make it so that we're going to create and we'll just comment out all of this stuff and just put it in a pass. It's the hard way. User, we can say, hey, guess what? If the, you know, is in group enemy, then let's queue free, right? Then we're going to say, you know, take damage self.damage amount. If we do this, what we see the problem with it is as soon as I shoot, it'll be like crash, wait a minute, it's going to collide with the player's the code image. And so now when we hit play and we shoot, it doesn't destroy the player, and guess what? Look, it works. We're able to do that. It's like, oh, that's cool. And very good. A couple problems with this. One of the problems is we power-ups, you have to shoot and like it blasts their shield. Like we can say other area dot has method. Now, method is just a member function. It's a function that belongs to call take damage. And if it does, we'll then call the take damage function. This cannot crash ever. This might crash. This can't crash. Why? Because we just checked if it has a take damage for argument one. And so does it have, I think people are getting confused. And as soon as but called take when you right, it doesn't follow logic stuff from the node to. So I'm going to go ahead and click create. Very cool. And I'm going to open this up. Again, what I've done, and I'm going to add it, and I'm going to create I created classes. And we could create a thing called damageable, right? Except you would typically not like all caps. You're saying like, failed my job responsibilities, and, you know, all that kind of stuff. You have a idea where an interface says like, okay, it has these methods, right? Has these methods, right? And it would be something like take damage is one of those functions, right? And it has like these properties, like, you know. So basically, this is how an interface works. And whenever anything, what we call implements damageable. So for example, under enemy, we're going to say, hey, it implements damageable. What that would then say is that this function or this code will crash if it doesn't follow the rules. It doesn't actually have a take damage function, and it will tell you, it'll say it's done, it crashes. And by doing so, by it committing to follow the rules of what damageable, hey, doesn't that sound a little bit better? And it crashes if it doesn't work, right? Instead of, hey, it doesn't work, and for some reason it's just not doing it. It just doesn't work. It doesn't crash and come back. This is where, this is going to be a little bit tricky for a lot of you, perhaps. Let's go ahead and create inside of this interface, let's create something called, let's create a class. And so if you don't know what classes are, I'm not going to take the opportunity right now. This assumes you know some basic object-oriented programming principles, like what a class is. I've talked in the live Q&A about how to set a class name, but you can create a class. This is what's called a subclass. It's a class inside of this interface GD class. That's okay. So it's a subclass. That's fine. We can define a class within a class. That's totally legitimate, even inside of GDScript. And so inside of this class, we're going to say that it has the function called take damage. And so far, this is totally legit, right? And it has, you know, we're not going to worry about the actual parameters. We could, if we wanted to, but we let's say we don't have time. And just so that it doesn't crash, we're just going to say pass. Because this, we're not telling you how take damage works, because everything's take damage works differently, right? Maybe someone has a shield, maybe something catches on fire, whatever. So take damage works differently depending on who is implementing this damageable interface. Okay, so we're just going to say pass, and we're going to let each class that implements this damageable function figure out what this take damage method means to them. So here we go. We have this class. It's called damageable. And then inside of enemy, we're going to implement that. Okay, we're just going to do it in an interesting way. We're just going to create a variable, and we're going to say implements, right? It's the same thing. It just has the word var in the beginning. And we're going to say an equal sign. So, okay, now we've got some equal signs and stuff. And we're going to say, yeah, Unfuzz like, what? GDScript has interfaces? It does now. So look, if you don't have any idea what I'm doing and it looks like I'm just a madman on fire, that's okay. Just, you can follow along. You don't even have to understand what it's doing. And if you get it to work through how I'm doing it, I want to design this in such a way that you can use it without even understanding really entirely how it works. If you know it works, great. But, you know, like how it works, that we got it to work. As long as you understand how to use it, that's what I care about. Anyways, so implements equals, I don't know, let's do, let's go ahead and say the class. So interface, oh yeah, it's an auto load, right? Remember, this is an auto load, so it's a singleton. We can access it from anywhere. Interface dot, what do we want to call it? We want to call it interface dot damageable, right? We spell this correctly. Did I spell? Oh my gosh! I called it interface. I wrote interface, folks. No, must fix. It can't be called interface. For the sake of all things good, it must be called interface. And now we must come to the project settings and fix it immediately. Remove, retry. It should be called interface. My gosh, interface. Thank you. Is it spelled right this time? Oh my gosh. How did this let me do this? This. And float an operator. Have I crashed something else by doing this? Self.position.y. Oh, did I delete something? No, I didn't. Hey! Maybe it's because the export... No, I didn't. Maybe it's because the export, it wanted it to be above. Hey! Thanks, GDScript, for being so particular about where I put my export annotation. All right, very good. It works. See, I love like making these mistakes in front of you. Done here. Again, now that it's spelled correctly. And cheating it here. So, okay, so now how does it actually work? So inside of laser, right now we say if other area has method take damage. Let's say, okay, that's neat, Control K. What I want to do instead is I want to ask if it implements that interface, right? So now what we can do is we can say if this implements variable is inside of other area. Okay, you use this in keyword here thing in order to check to see if this variable with this name is inside of other areas. So now if I hit save and I hit run, and we see ta-da, and then I shoot, and it destroys it, look! See, because it has the variable implements, right? Well, of course you see that's not all that helpful. Like, you know, if I say implements Z, then you'll see that it's broken. Okay, that's fine. Which is a problem that we're not really gonna be able to fix, but that's okay. The bigger problem though, is the interface doesn't even work, right? If I come to interface.gd and I like, you know, call this take damages with a Z, you'll see that it still works because all that we've asked of the object is that it has a variable named implement. And right, it also doesn't, I could implement something else other than damageable and this would still work. So we've got some work to do. Right? Yes, and so, I don't know, diffinoxd. XYD says like, yeah, but we have a string reference again. Yes, so it's not perfect because it's not really built into GDScript. But the nice thing though is that we will always use implements, no matter which script is using the interfaces. We're going to use implements, whether it be damageable or has shield or whatever the heck it is that whatever interface that we are going to define. We're just going to make sure that we write implements. Okay. And so therefore there's only one string. We're not changing its name because it's very cool. So we'll actually know this exists because we've checked to see it exists. And we're going to say if other area.implements is equal to specifically the interface damageable, right? So now if I do this and I go ahead and use the colon, very cool. Now when I hit play, and you can see that, hey, guess what? It still works, which is amazing. I love it. And if I wanted it to implement something else, like, so let's say we have implements, but we do make it called damage. No, so different playable anymore, right? Which we see if implements is another only work. Now, if it let's create a check. Okay, you are part of this damageable class. That's how we have to do it. This, I want to figure out, well, what is inside of this instance? And there is, let's go ahead and print. So I can print, and inside of the print, let's do like instance dot get method list, right? Something like this. Right? Instance dot get method list. So if I print this and I hit play, you can see, oh gosh, it has, let's get rid of this. Where did I put this? These like numbers, I think it was under player. Please stop doing this. That was from the live thing. We need to do check node. So let's do, this is just how you're gonna see, and I'm gonna hit pause. And then I'm gonna come back to the output. You can see that this is all the junk that's inside of any enemy that is spawned, right? Except it's not any enemy that's spawned. This is the stuff that's inside of, if you remember and you look carefully, not the enemy, because we're not doing node.getMethodList. We're getting the whatever the node's implement variable. This little, it's a dictionary, and the name of the function here is this take damage thing. Okay.
As the
signals in
The number of interacting objects goes up, managing the connections turns into a terrible mess. It seems inevitable to sacrifice reusability and modular design. However, I'm here to save you, so let's consider a simple scenario. Imagine we have a lot of different types of killer zones and killable objects. You probably want each killable to have its own unique dying mechanism. This forces you to keep the dying mechanism inside the killable object itself. The killers must have no clue what is going to happen to the killable object touching them. Otherwise, the killer code turns into a terrible mess of if jungles full of dependencies. This makes you think of Godot signals. However, any attempt to connect the killable functions to killer signals quickly turns into a spaghetti mess of function signal interactions. The solution everybody seems to be happy about is to use the has method function inside the killer object. At first, it doesn't seem to be a great sacrifice. Simply connect the killer body intersignal to its own function and see if the body has a method named, for example, hit. If it has, it must react to the killer, call the function, and we are done. Now inside each killable object, you can implement a different mechanism in its hit function. Everything seems okay, but actually, it's not okay. Let's say some of the killable objects are immune to some killer zones and show a different reaction. For example, the flaming dragon would be immune to the fire zone and would laugh when it touches it, but it dies if it touches the water zone. Now the question is, how on earth can a single function inside the dragon object laugh and die at the same time? And what are you gonna call it? Hit? The terrible solution is to get a reference to the zone and check if it's water or fire. Now the hit function does two completely separate tasks.
Single responsibility principle broken.
The dragon also depends on the type of the zone, and the zone depends on the name of the dragon function. What a mess! Step by step, a lazy implementation of a good idea turns your project into an unmanageable mess. But you don't worry, because you are subscribed to my channel. And here is a neat solution. Consider your TV set. It has a remote control and a display. The remote control is a completely different device from the display, but they work together. They are one module. We need to implement a similar system to solve the killer's killables dilemma. I separate the killer module into two objects, sender and receiver. The sender is the one responsible for emitting the signal. The signal is still connected to a function inside the sender. However, it does not call a function of the body touching it. Instead, it calls the function of its receiver. Adding the receiver as a child of the killable object, I can check if the body touching the sender has the receiver as a child. However, I don't want to hardcode name dependencies, so I let the sender get the name of its receiver as an exported variable. This way I can reuse the same system without touching any code. The receiver, on the other hand, has an exported variable which holds the name of the function of the killable object. To check if the system works, I print some messages. Let's set up the names in the editor and run the game. It works perfectly. Back to the dragon problem, let's add a water zone, a fire zone, and a new killable object called dragon. The dragon needs two functions, laugh and die. The player already has a die function. Let's make it react to the new zone types. Simply add two receiver nodes and name them appropriately. Don't forget to tell the receivers to call the player's die function. Do the same thing for the dragon. Make the water receiver call the die function and the fire receiver call the laugh one. Let's run the game. And it is working perfectly. You can expand the idea and apply it to totally different scenarios.
Godot are amazing. Signals allow the nodes in your scene to easily communicate with each other, without requiring a direct reference to one another. Signals allow the nodes in your scene to easily communicate with each other, without requiring a direct reference to each other. It allows a node or even a script to announce that something has happened without actually caring who receives the signal it emitted, enabling you to create flexible code that can be reused or repurposed. A simple example of this could be the ammo that the player holds or how much health they have. Godot signals are a version of the observer pattern, which is a widely used and known pattern found in a lot of different programs, languages, and frameworks. So you need to have a firm understanding of how they work in Godot in order to be able to fully unlock your game's potential. So what are the different kinds of signals in Godot? First and foremost are the built-in signals. These signals can be found in the editor on the right dock under Node. The signals here usually refer to built-in behavior and don't always need code to activate them. For example, you can use the animation player's signal animation finished to trigger a check on your weapon manager to see if that weapon is automatic and replay the animation. You don't need to tell the animation player anything. Simply hook the signal up where you need it and it will be emitted every time the animation ends, triggering the next event you need. You can use this to time certain events like coyote time with a timer node. Simply add one to the scene. All you need to do is connect the timeout signal to the player scene. When your player leaves the ground, start the timer, and if the player hits the jump button in time, then we can trigger a jump. Another good example is using an area 3D node to detect if a player is within range of an item or an enemy. The list is honestly endless. Every node has a bunch of useful signals that you can use for a huge array of different actions, so it's always worth checking there to see if there is something that you can use before doing something else. Not only can you use the built-in nodes, but you can create your own to be used within the editor, which gives rise to endless possibilities. All you have to do is use the keyword signal and then name your signal. Then when you want it to be emitted, you can use the signal name plus the method emit with whatever parameter you want to carry, or none. It can do both. Then, in the editor, you can go back to the node section and it will appear there. Double click on it and connect it to whatever you need. You can also specify if you have extra arguments here, but it's optional. And when you create the signal, you can simply modify the method it created to include arguments if need be. Sounds pretty great, right? Well, guess what? We're not done. Just like signals can be created via code, any signal can be connected via code. This can be really handy. For example, when you have a set of buttons in a UI, you need to connect to a button press signal. Or if you have a HUD element that needs to be triggered by an item that is instantiated in the scene. In my FPS manager, which you can download at chaffgames.com, I have projectiles that can be fired from a weapon. I also have the hit confirmation cross that pops up when you successfully hit a target. This projectile doesn't exist in my scene when I hit the play button, but I need a signal to be emitted by the projectile to the HUD when it hits the target. So how can I go about doing that? Well, I actually do it with two signals. Following the call down signal up principle, when I spawn a projectile, I emit a signal to the HUD, letting it know that this is the projectile that it spawned. When the HUD receives the signal, it calls a signal on the projectile called hit successful and connects it to the show hit successful function, which can be done.
First of all, we add the VBox container and 3 buttons inside it. Then we put the right text in each one, quit, oceans and start, and then we save the scene. Next, we create a script and then open it. Then inside the script, we create a function ready, we drag the first button and we do dot grab focus to focus on the first one. Then we create the signal pressed for each button to have their specific action, and on the first one we do get tree dot change scene to file we do, and on the first one dot in my instance on the last one we do get tree dot quit to quit the app.
Hello everybody.
Hey everyone,
Today, I'm
this
gonna
is
show
Brady,
you
the
how you
game
can
dev
make your
artisan.
UI
In
look
today's video, we're going
way better in Godot 4.0.1. I'm going to literally every button editor. Hello everybody. Today I'm gonna show Godot 4.0.1. Yes. So I have a control node and then I have a button. What I'm gonna do, I'm gonna create a new theme right here. Click on this, new theme, and now we have a new theme. This, when you click on this, it's gonna open this menu, which is the theme editor. Here we can change literally every button, line edit, text edit, tabs, lists, whatever. So let's say I want to change this button and how it looks like, right? All I have to do is come here, click on this little plus icon, and then select button. And now we get a bunch of different settings here. The most important one is this one. Here we can change how our buttons will look like in different modes, like when it's pressed, when it's hovered, when it's disabled, focused, or not, how it looks normally. Let's say I want to change its normal look. So I click on this plus icon, I create a new style box. And now all the buttons suddenly turned out gray. Now we gotta change that. We click on the style box and we get a bunch of different settings. Let's say I want to change its color. Click here, pick a color. Let's pick a nice shade of blue. That's nice, that's really cool. And let's say I want to add a border to this button. I can do that right here. I just set the pixels for each side and now we have a border around our button. The good thing about this is that you can like set pixels for only one side or two sides, you know. I can do like this, or I can do this, or no border at all. You can change the border color as well. And you can blend the border as well, so that it looks like, make your button not a complete rectangle, but this corners much better. Expand margins. This will basically just expand the margins of your button if you like. And you can also add a shadow to your button. You have to just set the size of the shadow you can like shadow and disable them. It's better I just show what. And then there's cussing. Yeah, this enables and disables anti-aliasing. And then there's content margins. This it's better I just show what it does. Yeah, basically. Let's say you want your button to be your text to be right here instead of in the center. So, how you can make your button look way better. Add a border, but only on one side. I added at the bottom. Let's make it 5 and see how it looks. I mean, this already looks like it's, but only on one side. I added at the bottom. Let's make it 5 and see how it looks. I mean, this already looks like let's pick this color and make it like, it looks really nice. The bottom up, maybe just a little. And also maybe just a little better. We go back to our theme to the look of not maybe just a little too much. Back to our theme to get to this menu again. You have to click on your control node and go to click here on the theme button. As you guys can see, this changed the look of not only button but other buttons as well. Now you might want to ask, why the hell did that happen? Well, it's because these buttons use button as a base. So any change you make to button will change these buttons as well. If you don't want that to happen, what you can do is click here. Let's say you don't want your checkbox to be blue. You just add your checkbox here. By the way, you can like switch between elements here. So let's say I don't want my checkbox to be blue. What I can do is click on this normal. Now I can edit this box here add another style box, what I do is actually I just like usually copy and modify it. Alright, let's paste it here. So let's say I want my checkbox to be another color, and I do that like this. So now if I come here, as you can see, my checkbox is a different color. When I hover over the buttons, as you can see, it turns back to the default look, and also when I press it too. That happens because we didn't edit the other modes basically. So again, what I'm gonna do is copy this, click on this plus icon, paste it here, and now we're gonna edit how our button is gonna look like when it's pressed. So I can make it like a little darker. And now if I press on it, as you can see, it's not the default look. We can also do this for the hover, paste it here. So I want to be brighter when I hover over it. And now everything looks perfect. Also, if you have a nice font, you can set a default font for your theme right here, and now everything is way better. So all you have to do is just, you know, set the other modes as well. Again, if you want to change like another item on this list, all you have to do is click here and just pick whatever you want. And let's say you want to change line edit. Find line edit, you add, and
to be continuing our series on visualization. The best practice that and the user interface, a new scene for the game. I can easily wrap in the world and the user interface layers. Before we do that though, let's take a look at our project file system overview and our scenes formation status. To get started, I'd like to first address our project's organization. The best practice that I found is if I use a new scene for the game, I can easily wrap in the world and the user interface layers. Before we do that though, let's take a lot of scenes and scripts. We can improve this by adding further layers of organization with folders. For example, we can bring errors for inside our tank types of weapons in there as well. New folder. We can bring our crate, the entities, for any UI, keep our world object. Call this game.tscn. Together your world 2D scene. And the goal of this scene is to wrap together your world and objects. So if we had multiple levels for our game, we'd want to be able to drag those into our game instance, which means our world scene shouldn't actually contain the tank directly. So let's go ahead and enter into our world scene. We'll remove our tank from the world scene directly and return to our game scene and add our tank scene back into the game. Make sure you save your world scene so that your game scene will reflect that. And here we can move our tank into a similar position and save that as well. Now that we've created this new game scene, let's go ahead and set this as our new main scene. When we play our game, we'll use the main scene to wrap any of our world and tank objects node called control node. Control nodes all have different behaviors for nodes instance, which means our return to our game scene, we can move our scene. Let's go ahead and set this wrap on our node of type and create a new scene layer. Let's go ahead and call it UI in all caps. This control node can anchor and scale based off the resolution of our screen, rectangle mode. You'll notice that when we select this, the bounds and anchoring, which are the green icons, scale to the resolution of our window. This is great for sizing and laying out your UI. Now for our UI, let's add some margin. We can do that by adding a margin control node called a margin container. We'll also take the preferences for this container and let it stretch to the full rectangle. An important note about control nodes is that the parent typically will control the behavior of all child elements. So if our control node root wasn't scaled to a full rectangle, the margin container inspector panel Now inside our margin container, if we go to our theme overrides in our inspector panel and expand the constants, we can add some padding and margin to the left, top, right, and bottom. Let's just do 32 pixels on all 4 of those for now. You won't immediately see this effect until you add children to the container. Let's go ahead and add a VBox container. Now you'll notice that our padding, or margin, has been added and our VBox container is taking up the full rectangle. Now for our purposes, let's go ahead and move our VBox container to scale only vertically to the top by shrinking to the beginning of the alignment. For our horizontal, we'll stretch from left to right. That's the default behavior. Next, we're going to span across the horizontal with a container called HBox. And inside our HBox container, we're going to add a label. Let's go ahead and call this label score. And for this score, we'll go ahead and give it a unique name so that we can access this in a script. Now let's add a script to our UI. Its name, we'll call this UI.gd. We'll also give this a class name of UI. Now we'll click and drag our score label with a control click, and we'll call this score label. We'll add some behavior to be able to keep track of our score within our UI. Now we'll set this equal to 0 by default and add a setter method. Now one behavior we'd like to introduce is the ability to update our label whenever our score changes. We can create a new function for this. We'll call it update score label. And for this, what we'll do is we'll take our score label and we'll set the text value equal to the string value of our score. Now, whenever our score gets set, we can use our setter method to automatically update our score's label to correlate. Read more about setter and getter functions on a variable in Godot's documentation. Now that we have this new function, let's set it as
We put the right text in each one, create a screen, and then open it. We do dot
Hi, I'm Somanimus. To do
and we put get tree dot quit to quit there when pressed.
By related. And what behavior we'd like to introduce is whether or not an on state, but more about elements on the screen.
Hello everybody. Much better. This looks actually copy and edit. We didn't Hello everybody. Hello everybody. Today
Hello guys, this is the Polyglot Programmer in my opinion. So we're kind of applies to a bunch of different aspects of life. Last but not least, a button. And if you master these 5 nodes, you can pretty much do a lot. Trust me, you can do a lot with only these guys, right? And we're gonna see that in action right now. So we have an empty project with create a simple menu. It could be like a panel in the back. What I want to is that you can come here to theme overrides, styles, and empty. Or it's really common. Let's add however you want. They're not particularly organized, except that if you wanna inside your panel, you can still use the anchor. So for example, I want to anchor this to the middle, I want to anchor this to the bottom, and there you go. So this is what a panel does. Hello guys, this is to add your UI node to theme override. Actually, before I add a button, no, I'm gonna add a label. My menu, great. And this is here, great. And now if I pick my VBox example, I really have the anchor options. Just like for example, if I pick my VBox container, since that the direct parent of that guy is a panel, I have my anchor presets over here. If I click on my label in my button, I do not have the anchor presets. I do have the alignment ones, which are not exactly the same, but everything that I add in here, they're gonna be one on top of the other. So let's just make this yeah, and again, let me just make this a bit taller. No, this is too much. This is, yeah, duplicated this guy. Now I'm just gonna add another button, right? I've just duplicated this guy, button 2, right? So for now, what do we have here? We have a panel, right? We have which respecting that you add in here. So for example, other button here can have a minimum of stacked on top of it. I'm actually gonna go ahead and we're gonna add a HBox container, and this is one on top to the other, right? So the things here. So I have a VBox container. Yeah, and let me just duplicate this button. I'm gonna use another button again. I'm gonna drag this third button here inside my VBox container. Right, and now I'm just gonna duplicate this guy, right? So what next to each other, and as you can see here, this guy started to organize things one next to each other. And since I do not have in my layout here, I do not have a minimum X value for this, then it's taking the value of the text, right? But this is not pretty. So one thing that you could do here is that you could play with the alignment, right? So for example, if I have this horizontally aligned, this would be beautiful, right? And the same I could do here. Yeah, and this yeah, And now this guy, instead of this, I'm gonna have this. There you go. So now I have my buttons. Let me just run this. Select current. Now I have my buttons aligned to these sides because I told them to do this. But styles and empty. There you go. There you go. And let's right things are gonna. I do not have. My menu.
Ayo, mercy.
We're on the beat.
You son of a bitch.
DPS in the beach.
It looks like he's talking to a small pig.